Okay, we're going to go over linear problem solving, and in this example, we're going to solve it by graphing the equation. Okay, the problem that they've given us looks like this. It says Lee works in a greenhouse. He needs to plant 32 bulbs. There are two types of bulbs. He's told to plant 3 times as many crocus bulbs as tulip bulbs. How many should he plant of each? Okay, so I've read it once. I'm going to gather important information. Lee works at a greenhouse. Okay, that's nice. He needs to plant 32 bulbs. This is important to us. There are also 2 types of bulbs. Okay, that's going to be important, but I remember in the next line they specifically tell me what the types are, so I'll highlight it in the next line. He's told to plant 3 times as many crocus bulbs. This whole sentence is important. As tulip bulbs. Okay? How many should he plant of each? Okay. So we're going to need to make 2 equations. The first thing we need to talk about is how many bulbs does he need to plant altogether? Anyone know? 32. Okay? So we know he needs to plant 32 bulbs. Okay? Do we know how many he's to plant of each? Crocus and tulip? Not yet. That's what we're trying to figure out. But we know there's only 2 types, as they said. So what we're going to do is we're going to set up our variables as crocus bulbs and tulip bulbs. So let's say C equal crocus, and let T equal tulips. Okay. So in other words, 32 bulbs is going to be all of our crocus bulbs plus our tulip bulbs. So that's our first equation. Okay. Our second equation says that he needs to plant 3 times as many crocus bulbs as tulip bulbs.
32 plus 3c plus t.
Say it again.
32 plus 3c plus t.
32 plus 3c.
No, 32 equals 3c plus t.
32 equals 3c?
Yeah.
Okay, that won't exactly give us what we need here. Okay? What we're going to be making is we need to make a comparison between the 2 types of bulbs. Okay? Our 2 types of bulbs, we have our tulips and we have our crocus bulbs. And the comparison is comparing the 2 types. It says 3 times as many crocus bulbs as tulips. Okay? So in other words, let's think of this as an English sentence maybe. The crocus bulbs are going to be equal to how many times the tulips? 3. Okay? So no matter how many tulips we plant, 3t, we're going to multiply that number by t, and that will tell us how many crocus bulbs we need to plant in general. Okay? So this is our second equation. Looks a little harder to make, but that's our second equation for this question. Now, we're going to graph this. So, another thing I want to do, when we graph, we use the variables usually x and y. Right now I have c and t. It doesn't technically matter which I call which. But what I'm going to do is I'm going to call the crocus bulbs our y variable. Okay, so again, let c equal y and let t equal x. This way, it's a little simpler for myself to graph. You don't have to do this. If you're able to tell what the crocus bulbs, the tulip bulbs, and what axes you want to put them on for graphing, that's fine. But I've done this for simplicity's sake. So let's bring down our graph. Okay. Now, let's look at this graph. This is going to be a little harder to solve here. But what we have is the number 32. Since I've set c to y, let's rewrite these equations. We have 32 is equal to y plus x. And I have 3x is equal to y. Okay, well in terms of graphing, the second equation is all set up for our graphing. The first one I'm going to need to rearrange. What will I need to rearrange it to? Pardon? What will I have to set it equal to, the first equation, in order to graph it? Y. So in order to set the first one equal to y, I need to move x to the other side. So we're going to get 32 subtract x is y. And our other equation is 3x is equal to y. Now, when we're looking at our y-intercept. I don't have a y-intercept in the second equation, and in the first equation, the y-intercept is 32. So when I quickly take a look at my graph, my y-intercept doesn't even seem like it's going to fall on this page. So I'm going to need to do something that's going to work out a little better for us here. Okay? Let's say I can always move it into tens and estimate, but that won't be very accurate for our graphing. And this is the problem with graphing sometimes, is we sometimes have to customize our graph in order to get the exact numbers. Okay? So let's see if I have any graphs by maybe scale of 20. I don't have anything by the scale of 5, so I'm going to have to make my own graph. Okay? So we'll do this on the other page, and then we'll bring it over. So we're going to have to make this graph. How many slots are there? 1, 2, 3, 10. If I go by a scale of 3, am I going to get up to 32? No, that won't quite work yet. What's another good scale we can go by? 4. But the problem is, and let's go back and take a look at our graph before. Let's go to dual page. If you take a look, the next thing I want to talk about is our slope. Our slope here is -1 in the 1, and our other slope is 3. Okay? So we want some graph where we're going to be able to make a slope of -1 and 3. Okay? So maybe I need to actually make a very large graph, because one of the slopes is going down 1 over 1, or I could always go down 3 over 3. That one's easy to make. The other slope is 3 over 1. Okay? In other words, our rise is going to go up by 3. So I'm probably going to want a graph that actually goes by 3s. Okay? Or if not, maybe even 6. 6 is a multiple of 3. So if each of these spots goes up by 6, I know half of it would be 3. So I'm going to remake my graph to go up by 6s. So we'll zoom in again on that other page. And we'll go up by 6. So we're going to have 6, 12, 18, 24, and 36, 48, and 60. Okay? That one goes up by 6s. If you notice, I just skipped the middle one just so I could fit all the numbers in. On our right, though, we know we need a total of 32 bulbs. Okay? Again, if we're going over 32 bulbs, we can make that one maybe go by 3s if we'd like. But it's usually easiest if we make a scale either by 1 or consistent with our other scale here. Okay? So remember, our rise was always 3 and our run was 1. So in this case, maybe we'll go over by, well, we know our scale is going to actually have to end at 32. If this is our crocus bulbs, and these are our tulips, right? Remember, that's how we called our X and our Y. We know that this scale is also going to need to go up by roughly that same amount. Okay? So we're going to use equivalent fractions when graphing this to figure it out. So again, I'm going to make this one go up by 6 also. 12, 24, 36, 48, and 60. Now this is going to be a tough graph to work with. Maybe not the best. If we take a look at our equations from before, we started at 32 and we had a negative slope of 1 over 1. Okay? Well, in this one here, 32 is not going to fall right in the middle. This is a really tough graph to work with. All right, I'm going to make a giant one. We're going to get rid of this graph just because it seems like it's going to be far too complicated to work with. And what we'll do, we'll try to go up by maybe 2s in this one. So help me out here. How many slots do I have altogether? Anyone know? We go by 75. 1, 2. 15, 16. 16 is half of 32. That'll work this way. Okay. Okay, we know that one has to start at 32, and our other number of slots, 1, 2, 6, 7, 13, 14, 15. If I move it over 1, I'm technically at 16. So what I'm going to do, I move this right to the side of the page. Okay, and our other one's going to go right to the side also. So this scale is going to go up by 2s, and I'm going to draw it on the inside. We have our 2, 4, okay, and I'm just going to jump 8, 16, 20, 24, 28. This top one here will be our 32. And here we need to do the same thing. 2. No, this one has 2. This is 4. Oh, sorry, I wanted that one to go up by 1s. I'm having trouble making this graph, eh? Last one, 16. Okay. So we've kind of piled all the information in here. Zoom out just a little further if we can. If you guys remember, our graph was 32 minus x was equal to y. And our other one was 3x was equal to y. Okay. Well, 32, we know we're going to be starting way at the top of this graph. And we're going to be going down 1, over 1. Okay. But because these are different scales, this one was going up by, each of these slits goes up by 2, or each of these lines. And this one goes up by 1. We have to keep that in reference when graphing. This is a tough part about graphing. If we have different scales, we have to keep it in mind. So, if a movement of from here to here on the x is 2, that's only a movement of one spot here. So this would be going down 2, over 2, which would be the equivalent fraction of -1 over 1 or -2 over 2. Okay, so this part's very important. We go down 2, and we'd have to go over that same amount, which is actually 2 spots here. So this is a slope of -1. Even though it looks like down 1 over 2, because our scale is different on the graph, this scale is going up by 2s and this one's going up by 1s, our graph's going to look like it's going down 1 over 2, but in reality, we have a slope of -1 over 1. Okay? So we're going to continue that pattern. Let's set up our line here. Okay, so we have our line for the very first graph. In the second one, our rise over 1 is up 3 and over 1. Well, this is a scale of 2, so we're going to have to think about that's going to be halfway in between and over 1. So let's make our scale. We go up 3 and then just over 1. That would be here. Up 3, over 1, up 3, over 1, up 3, over 1. Up 3, over 1. All right, and let's connect our dots here. So, by graphing this, we finally find a point of intersection. What is our point of intersection here? What's our x value? 8. And what's our y value? 24. I know it looks like a 9. Now, what was our x value standing for? Tulips or crocus bulbs? Anyone remember? Tulips, that's right. We're looking at tulips for x. So this is our tulips. And our crocus bulbs were 24. So, the toughest part about this question is setting up a proper graph so that I can actually find a point of intersection. If you guys notice, it took us about 2, maybe 3 tries to set up this graph. Usually, the best way to solve a linear equation is one of our other methods, substitution or elimination. This graphing method worked because we had whole numbers. But we might have ended up with a different type of question where they were working with decimals. And the working with decimals would have caused us a lot of difficulty in order to solve this, because then we would have been estimating how far between. Okay? So if a question says solve by graphing, that's great. I know you guys did a lot of graphing last year. Go for it. But in any other question where you think it may not fall on the whole numbers, substitution elimination may be a good method to start using. Okay?